Next.js is a very powerful framework, and it gives us a lot of features that are very useful, but it's also very easy to misuse them.
Actually, this time we're going to dive deep into the server side of things. Whenever there's a limit of how much you can achieve in the client side, the issue is very often server.
And we were noticing that on our worst days that we had 2 requests a second a pod on our Kubernetes setup.
It's a bit bizarre that now front-end developers have to worry about those kind of things.
Because Kubernetes is a very powerful tool, and usually is chosen by many teams.
Moving all those server actions to normal GET requests got us from 5 requests a second to 8 to 10, so almost double.
This creates a whole different world comparing to a regular React application. Hi, welcome back to the Next Gen Web podcast, and today's episode will be handling the performance topic, but not as the usual from the client-side perspective, but actually this time we're going to dive deep into the server side of things. So whenever there's a limit of how much you can achieve in the client side, the issue is very often server, because Next.js renders at the server, so we will be taking a look at what might be causing it and what might be potential solutions. I'm here with Tomasz. Can you introduce yourself?
Sure. My name is Tomasz. I am solution architect and also full stack engineer working at GFT company, but also I am supporting and working at Blazity as a solution architect, and I'm really happy to be here. Thank you for inviting me.
Yeah, I'm very happy to be here with you too. We'll be going through the most common issues that are happening on the server side, because this is the very popular issue right now on many different applications, and there are a bunch of different issues that can actually be causing the performance bottlenecks. So for all the people that actually have the similar issues, we'll be just mentioning some of them and going through solutions and what can actually be causing them in details. Let's start with Next.js maybe. This creates a whole different world comparing to a regular React application, just because we have this server layer that is first rendering the page and then just sending it to the client. So server delays can cause LCP delays, FCP delays, and all of the different delays in the content that the user is seeing, like it was on the client side. But actually, the issue is very often on the server side. There are a few indicators that we can check and see if the actual server side is the issue. So we'll be starting with Next.js specifically before we're going to go into the infrastructure. With Next.js and any other backend framework application, there's potential of delaying the first initial response. There are a bunch of different indicators that you can check if the actual server is the issue, but one of them is time to first byte, for example. This is a very clear indicator that if the time to first byte is high, it happens before even the HTML is served to the client. So this is a very strong indicator that actually something might be wrong on the server side or infrastructure. But also the thing that you can identify it with is by having an FCP that is the same as the LCP. When you want to optimize for LCP, which is like the most core web vital for how Google is scoring your site, you want to minimize it, of course, but if it's the same as the FCP, that means that the content is rendered right after it's being delivered to the browser. And if you're using server-side framework, if you're actually serving content from the server, it means that there is some room for improvement if it's slow, on the server, not on the client. Okay, so we touched briefly of how can we identify that the issue is actually happening on a server, but Tomasz, can you say a couple of things of what are the most popular issues that can actually be happening in Next.js specifically?
Yes, sure. I think there are several of them. Next.js is a very powerful framework, and it gives us a lot of features that are very useful, but it's also very easy to misuse them. Mm-hmm. And for example, when we have too many server-side rendering requests, we need to bear in mind that behind the scene, there is a Node.js engine, which is single-threaded event loop. So if one request is slow, then blocks others. And so if there is no caching, that every request go through the same cycle, re-rendering the whole page, business logic, etc., etc. So this has a huge impact on performance. Another point I think is worth to mention is the API routes, which are very convenient, I would say, for prototyping. It's very easy to write API call. API method that are managed like a typical API servers. For developers, it's very useful But if we have some large operations done within it, like database calls or some large JSON parsing or image processing even, or some DB calls, etc., they are very heavy. And then at the end, they all compete with CPU for rendering. So if there is no some external services that may hand over this load, then the server is overloaded because, as I said, there is a Node.js behind, which is single-threaded event loop. Yeah.
Mm-hmm. And now we're talking about like a Next.js application hosted on your own infrastructure, right? And like being containerized. Mm-hmm. Because if we're, for example, running application on Vercel, this specific problem is not our issue because like Vercel itself is handing it over to different lambdas and to like the fluid computing and whatever they are now using. So it's not the problem of a single instance, but we're talking specifically of like self-hosting the Next.js and Dockerizing it, right?
Yes, because most of the companies, which are enterprise companies, at least they I experienced or work with, they self-host Next.js, whether this is Kubernetes or AWS ECS. But usually it's not like they use some already built up tools for that, like AWS Amplify, for example. Usually it's this Kubernetes. I think Vercel manages this very clearly because they somehow under the hood. I don't know the details, but as you said, there are some lambdas that are provisioned for this server actions. So the issue is somehow mitigated. I'm not sure what's exactly going on there, whether there is some reverse concurrency for each lambda, so they also don't have to be throttled or what. But at the end, somehow it's managed. But still, I think that Next.js should be focused on rendering and the stuff like DB calls, parsing some large JSONs or image processing, which can be easily just move out to some other service which is designed for it specifically. I think it's much better than just having coupled everything within a Next.js and trying to do everything within a front-end framework, I would say.
Yeah, so basically offloading as much as possible the server from doing anything else than the rendering. I think that's a good like rule of thumb to keep. That everything that is not actually necessary for the page render, if you can move it outside, then just do. I think that there's a lot of benefits that can come from this approach. Of course, there's small like API routes that are just used for tracing or something like this are probably not the problem. But the event loop is real, but the JavaScript and the Node.js is still a single threaded. So yeah, it's worth to keep in mind.
Exactly. And there are some other things that we need to bear in mind, like for example middlewares, which are, as we know, they are triggered before every request. So if we also have some heavy logic in there, it simply adds additional latency on top of every request. And for example, simply authentication check, which is done within middlewares, can add around 150 milliseconds to every request. So we also should bear in mind that it's not cost-free, and keep it as lightweight as possible. Yeah. Mm-hmm. And for example, edge functions. I've seen a situation that edge functions were used to retrieve data from database. There were done some requests from edge functions, which is from my point of view misusage of this feature, because database obviously usually is not distributed across the locations. It's centralized. Can be, of course, some few locations, maybe like multi-AZ can be enabled for some, but usually we don't distribute it over CDN locations. As a result, the response time was very bad, and the outcome, the efficiency, the entire efficiency from this was even worse than centralized server-side rendering request.
Just based off the whole trip that the request has to make from the edge case, yeah.
So we didn't take advantage of using edge functions, which are distributed in several locations, because they all were trying to get the data from one centralized location anyway.
Yeah. So the potential improvement was actually slowing things down and helping.
Yeah.
And you touched on something else. This is a separate problem. Like this is not the resource related, but actually waiting for the connection, waiting for some additional external sources. This is one of the also very common issues in Next.js rendering specifically, when you have a React server component and you have a bunch of different dependencies. You have 5 different calls that you have to make to get data before rendering the page because it's async. The waterfall effect is becoming more and more significant with each request that you add. Even though the requests can be very quick, they can be cached, but the delays with consecutive awaits, and like all of them have to make the handshakes. All of them have to connect to DNS, and it just takes time when you add it together.
Yeah, exactly. Another thing that maybe we can consider here is the usage of app router. As we all know, it was introduced around maybe Next.js 13 as experimental mode. I don't remember exactly. And prior this was Pages router, which from my point of view was a little bit more predictable in terms of server-side rendering or server-side generation. Obviously, the bundle itself was heavier because it contains more client code comparing to app router. But we could somehow predict what the outcome would be from the code that we are developing. But when the app router was introduced, some developers, I think they thought that maybe they can move out the logic from client to the server, and there is no cost of it. It's completely free because app router introduced React server components or streaming, which helped us a lot with hydration process, which now is partially happen. So we even can select the section of the page that you want to have hydrated in the first place by clicking on it. So from the user perspective, it's very, very useful thing. But we need to also adjust the way we build the code, that now when we use those functions, they are run within the same runtime as the application itself, and there is still behind Node.js single-threaded engine, which also needs to consume all of this. So it's not like the cost-free. So I think we should balance a bit React server components with caching, with memoization, and with selective client components in here.
That's a good thing to mention. Before with the Pages router, it was much more predictable. When you had it was it was almost impossible to make a mistake of what type of rendering you will get. It was the whole site would have to be one single render, of course, the type. But if you use get static props, get server side props, it's very, very explicit and very hard to miss. Right now, it's a simple cookie call, and the layout component can turn all of your application dynamic without you even noticing it.
Yep.
And there are some indicators, of course. If you build it, you have different markers for the pages that are dynamic and the ones that are actually static. But right now, it's we have much more control, but it's also easy to make mistakes.
It is flexible, but easy to do mistake, as you said, yeah.
Okay, another issues outside of Next is that your application might be bottlenecked by your infrastructure itself. So even though all of the application logic, the framework you're using is fine, but there might still be some issues with how and where is it actually run. Tomasz, do you have any examples of the issues caused by infrastructure that people might be experiencing?
I think there are several. If we are talking about Kubernetes specifically, so let's stick to it, because there are several layers that we need to deal with, and there's a lot of places that we can misconfigure. What doesn't really happen when we use, for example, Vercel. But let's stick to Kubernetes. I think there are a few things that there are plenty of places that we can misconfigure something, but at least some that I've seen, three most common mistakes is maybe we can dive into those a little bit later in the second phase of the podcast, but maybe I can just point it out or give some short description. So first one is the Nginx ingress controller, so buffer, which holds the response from the pods itself. And if it is not big enough, then rather than just keeping in memory and responding to the user efficiently, Nginx try to flush the data to the storage using temporary files, which definitely increase the latency. Another one is maybe keepalive connection reuse. And this is also quite common mistake, that every request that goes through load balancer and goes to the pod and Nginx has to have another handshake. So set up the TCP TLS connection to be specified. And this also uses pod resources. So Node.js and CPU behind is not used for rendering, but instead for handshake. Mm-hmm. And the third one, which is worth mentioning, is session stickiness, where we have situation that the request is attached to the specific IP address that's what used before. And if there is plenty of requests from the same IP, which may happen because we we may have situation that some organizations have NAT gateway in front of the network, and there is like 500 users that goes to the same page. They all have the same IP address. As a result, one pod is completely overloaded, whereas the others stay idle. And one pod consumes in proportional amount of traffic. And what is more funny is that, not funny, but interesting in this point is that HPA, so horizontal pod autoscaler, is not triggering scaling because still sees that 2 pods are not used at all. There are still capacity that can be used in here. So and autoscaling as a backup doesn't work. So it's also a very common issue. Maybe later we can go more into details. These are the most common issues that I run into when it comes to Kubernetes being set up specifically for Next.js application.
It's a bit bizarre that now front-end developers have to worry about those kind of things, but we mentioned a bit how can we know that the issue is on the server side. How do we know that when it comes to we have another division here when the actual issue can be. So we have either the application of our site or like I said, infrastructure that we just mentioned. If this is a problem with actual Kubernetes, what are the indicators? Like what experiments can you do to narrow it down to know for a fact that the issue is on the infrastructure and not in your application code?
Well, I think definitely we need to set up observability, some tools on the Kubernetes end to try to find the real root cause and not trying to sniffing around and guess what exactly could go wrong. If we are able to retrace the steps of some requests and see in which specific place something went wrong, then it's easier to spot the bottleneck and make assumptions whether this issue is on the application level or infrastructure level. However, if there is no clear information about that, I will first go and try to optimize application. Because if we don't have optimized application or we are not sure whether application is optimized, then it's hard to optimize infrastructure because we don't know exactly how far we have to go in terms of CPU limits, memory limits, pods numbers, etc. If we don't know if the application is not optimized. Because if we do other way around and try to adjust infrastructure phase first, then it's like a band-aid, in my opinion. And then application is optimized and may turn out that infrastructure now is cost too much because has too high resources attached to it. And now we should go down a bit because application is better behaving. So we need to do the work twice. That's why I will go and fix the application in the first place, then tweaks the infra, what can then afterwards brings the real benefit. So observability, I would say, is the tool that must be set up at day one in every project. It will definitely help us find the root cause of issues. Otherwise, as I said, there are so many layers or places that something can go wrong. So it's very difficult to find them without an observability. It's must-have, in my opinion.
When it comes to the Kubernetes and pod specifically, for the virtual CPU units that are required to run Next.js application, is there any gold standard? Because there are some people that are saying that more than one CPU core is better, just because there is also this event loop in the background that might actually be beneficial to have some additional resources.
I would say that it's not written in stone or somewhere written. I would say that definitely we should have at least one CPU for Node.js application, because especially when it being run in as a container service, which also has some file system within it that also consumes resources of CPU. And when application is based on Node.js, which is single-threaded event loop, having like less than one CPU for managing everything, I think is not right. It's not right. So I would definitely go with one. If we struggle with some bottlenecks and if we suspect that something is wrong with the pod, and there is actually less CPUs than one, then it would be my first guess to do so is to increase it a bit, to have at least one and something. This definitely may help improving the performance and speed up the response time.
And if you have only one virtual CPU, is it worth to experimenting if it actually helps with the bottlenecks?
Well, it depends on the amount of requests that we receive, because now we can touch situation whether we would rather to have vertical scaling versus horizontal scaling.
Yeah.
I would say it depends. I would recommend vertical scaling in the first place and keep horizontal scaling as a backup, because horizontal scaling is not instant. There's a cold start, the pod needs to be provisioned, pulled image from registry, networking attached. It always takes some time, up to even 120 seconds, depending on the specific use case. So first of all, I will definitely go with vertical scaling and have some strong pods that can manage Node.js requests for sure. And if that's not gonna work, then we can consider horizontal pods. But this is theory, and it always has to be investigated. We need to align this approach to the current use case that some clients struggle with. So not always vertical scaling will be fine for someone. Maybe there are some situations or issues that actually horizontal scaling would be better or better fit for this use case. But essentially we can try with increasing CPUs if we struggle with requests and see if that brings any relief. And if not, then we can search for some other solutions or other bottlenecks.
We are talking a lot of performance, but we have talked about a lot of the performance on the client side. And today we are switching things a bit because this is only the one side of the whole picture. But we have one more guest. Trystian, can you tell a couple words about yourself?
Yes, I'm Trystian. I'm from the Netherlands. I'm working at Decathlon, which is a large sport retailer around the globe. Very big in retail stores, but also online. I'm working there as a staff engineer and mostly on things like developer experience, performance, server setup, and load testing. And we are today here to talk about Nextjs.
Yeah, definitely. That's all we do in this podcast. Let's maybe talk a bit briefly about the issue that you are having before you reached out to us, Trystian, if you mind.
Yes, so you make a great point. We are basically moving the front end to the back end with Nextjs, and that's something which is forgotten by the developers sometimes, that we are running things on the server. So we are just coding our websites and like we used to do and building big React applications, but in the end we need to run it on a server. And we were noticing that on our worst days that we had 2 requests a second a pod on our Kubernetes setup. And that is very low, especially if you ask backenders who run backend services. They're like, hey, can you only serve 2 requests a second on this pod? So we were investigating a lot how that is happening and why that is happening. And I think we're going to talk a lot about that today.
People are very often like, when we only had React, it was much easier to optimize because we only had to worry about the actual client side. But now we have this server that is actually, we have a lot of benefits from it because we can serve the content faster to the user, but optimizing it also creates another like runtime environment problem because it's no longer the browser and it's no longer easy CDN that is serving the content, but actually right now there's a lot of server work. Today we're going to be talking about this specifically. And when it comes to the issue that you were having, how did you find out that you actually have the issue? Did you have any monitors set up?
Yeah, we were noticing that for the bigger countries, we were running a lot of pods, over 100. So that was also one thing we noticed, and we were like, hey, why are we running so many pods for our application? And then we started request a second and then divided that by the amount of pods. And then you're like, yeah, we are only serving 2 to 5 requests a second on those pods. And the time to first byte wasn't great. You can easily see how all your backend services are responding and the response times of that. And then you know how much time is still spent in the Next.js app to actually send things to the browser. And we were noticing that time to first byte times got very big. And especially with running Next.js on the app router, you can very easily stream HTML to the user and have a very quick time to first byte. So those were the first things we noticed. And after that, we also saw that some pods were crashing and restarting and failing to scale up the load.
Okay, so you notice it by the horizontal scaling and also the time to first byte. Time to first byte is probably the very explicit indicator that something is wrong on the server side. So
yes, indeed, because then there is no client involved yet, so you especially know that it's on the server. And then we started, of course, digging into our monitoring, like CPU usage and event loop lag. And then we saw big spikes in the CPU usage and the event loop lag growing. So that was also an indicator like there's something wrong.
Did you notice any like business impact for this specific issue? Like, was it something that happened right away, or was it a long ongoing issue?
Yeah, so if you are running a lot of pods and some pods are not working, of course, a lot of users still have a great experience because they can just search the website. But for us, if you see in your monitoring and dashboarding that some pods are failing and restarting, that has user impact because users were trying to access the site on those pods. So yeah, there was definitely user impact as well. And we had some outages as well that the site wasn't reachable at all. And that triggered us to really solve things because I think that's normally you can see all your monitoring and logging, and then you say, oh, there is something wrong. But until a real outage, then people are really going to solve all kinds of things. So in this case, it wasn't that bad that we had that outage. But of course, for the user, it is really bad, and we should have prevented it earlier.
Trystian, well, I understood that before the fix was introduced, there was like 100 pods being run to manage the load. Is that correct?
Yes.
And after this improvements that you guys did, how many pods do you have right now?
Yeah, it depends on the load per country, of course, because if you have a big country with like 700 requests a second, then you need at least 100 pods. But we are now with the fixes going towards 10 requests a second, so still on the low side. So but we need less pods to run a country, so it will be a little bit less than 100, but it's still dependent on the traffic. And especially with e-commerce, you have seasons like Christmas and Black Friday where you have an increase in traffic. So then you will start scaling up again. So cannot say if you're really below 100, because at times we can be above 100, but it's really about how many requests a second can we serve on a pod, and how easily can we scale up without filling up the pods immediately with high CPU usage and a lot of requests a second.
Yeah, and also it can impact the cost of the whole infrastructure. If you are scaling unnecessarily too much, then definitely that can have an impact. And one thing with scaling one single application is that it's very often, because sometimes it is, but very often, most likely for Decathlon, it's definitely not a single service that you have to scale. Because the more like scale you have for the web service, then the more the API hits you have, the more backend database reads you have, and stuff like that. So there might be just simply horizontally scaling is fine to the point when other services aren't becoming a bottleneck, right?
Yep.
So it's also something.
Yeah, of course. And then other services get slow again, and because if you have slow fetches, our next app also gets slower, and then you get hanging requests, which also lead to higher CPU usage. So it's all connected to each other, indeed.
Mm-hmm.
Yes, and I think we need to also take into account that horizontal scaling isn't instant. So if there is a huge spike, then we still need some time to provision new pods, because some images needs to be pulled from registry, warm up, so cold start, etc., etc. So it's not like we can instantly provision additional pods that will manage the huge spike of the requests. We can definitely mitigate the issue where there is no enough capacity to consume all SSR requests, but some of the users for sure will see timeouts, because it's not possible to reduce it completely. Having inefficient application and scaling on infrastructure level is like scaling inefficiency. And that's why it's so important to resolve issues on the application end in the first place before we jump to infrastructure and trying to find the bottlenecks there.
Yeah, of course, it's always easy to throw more computing power at it, but that's not always the solution. And
Exactly.
I think you also need to scale on time. So like maybe if you have 70 to 80% CPU capacity, then already scale some new pods to not let the other pods crash. So that's really important to test it out and see where your sweet spot is with scaling and HPA settings.
Yes.
Yeah, definitely. Okay, I think we have a pretty good understanding of an issue that you are having, and I'm sure you are not the only one that is actually having this issue, because this issue is actually quite common ever since app router of Next came out. It's automatically created a much more load on a server than, because previously it was that the idea was that it was very often like everything you could do static was static. Now with granular caching and all of the optimization you can do, it's actually much more convenient to have more dynamic routes than before, just because, for example, simple A/B testing, if you want to do it properly, you should also start from the server and not from the client. So it's becoming much more and more popular, and it's just becoming a more demand for the server computing power right now on the web. So I'm definitely sure that you are not the only one with this issue you were struggling with. And if you could share some points that you started to investigate with, like what were the potential issues that you were starting to look for?
So I heard a lot in the industry that people are facing this issue also with the pages router already. If you make a lot of dynamic pages, because rendering React on the server is quite heavy, and then you cannot serve a lot of requests a second. But indeed, you're touching up on a great point, because we want to serve more static pages, but due to the experimentation, that's very hard to do, because business wants to experiment on parts of the page. And then we need to have a dynamic page, because you want to have variations, or we need to make up a system that you cache like 10 variants of one page, and then through the routing have experimentation, but that makes it even more complex. So we are really fighting those kind of decisions with business and tech. Which way do we want to go? We also want to experiment and have a great website, but we also want a fast and reliable website. So we are making the web way too dynamic nowadays with all the things we can do, where you can just also statically serve some pages. So the first solution we are looking into is, can we use static pages for some pages which don't change very often and aren't that business critical? But then we are still facing an issue. We investigated that, and it's only around 1 or 2% of traffic, which will help a lot, of course, on the total picture. But that's the first route we are going to go to see if we can, with ISR, do some pages, start with the smaller pages, which are easy to do, have in an architecture for those pages, because they are quite different than the dynamic pages, because on the dynamic page, you need like the experimentation and other dynamic values in the page. And after that, we are going to look into the more complex pages. Is there a way to make them static, or cache the most popular ones, like the 100 popular one, cache those on the CDN to give our infrastructure a little bit more health. So I think that's also what you guys advise, like do more static generation, because that will help the performance a lot. But that's very hard due to the experimentation and other dynamic things. The other solutions we are looking into is getting more strict timeouts on our API. So we really see that there are no fetch requests hanging, which are blocking the whole server from rendering the React and blocking other requests. Also the load balancing, we are now load balancing on CPU, but maybe we want to load balance on event loop lag or other values. Another interesting idea we got, and we can later on touch upon some of these points, because I'm now going fast through them, but that is maybe have dedicated pods for certain pages. So send all product pages to one dedicated group of pods. So they serve the whole application, but the product pages go to one pod, so they utilize the Next.js cache better. Because if we are round robin all the requests, and then it's just a chance which pod gets which request, but then you don't have an advantage of the Next.js caching system, because the chance that you hit the same page on the same pod is very low when you're running 100 pods, of course. But if you're sending almost the same pages to the same pods, that cache hit the chance gets higher. So we want to investigate with those kind of things if we can give the server a little bit more room and utilize the Next.js app more. And we have other things which we want to solve. I can also, we solved a big issue with using server actions, right? So we were using server actions as GET request, which you shouldn't do because server actions are actually built for mutations and primarily to be called when you click a button on the client. But we were using them on the server to get data while rendering the page. But the problem with that is a server action is automatically converted into a post. And when we navigated away before that post was completed, it kept hanging on our server. So no timeout. And then we saw in our logs that we had requests taking like 6 minutes because they were never resolved. This came to the light when we, on a list page, added a lot of next links, which pre-renders the next page where it goes to. And that was calling those server actions. And then we had a lot of hanging requests. And actually moving all those server actions to normal GET requests got us from 5 requests a second to 8 to 10, so almost double. And the time to first byte decreased by 300 milliseconds. So it went from like 1 second to 700 milliseconds. So that's a big improvement. And those kind of things, we are very happy to find them, but it scares me also a bit that like a small thing like a server action which is misused can have a lot of impact when you're running Next.js at a big scale.
Yeah, definitely. Server action is actually like a common trap that people are falling in because it just seems very easy to use. The API is very nice and it's convenient, but documentation for some time ago it didn't say it. About the thing you just said about using server actions on the server side. It's basically it's spinning up a separate process just to handle this action. Even though it's in the same environment, it doesn't optimize it to just call it in the same runtime. It's actually created a whole separate. So depending on the environment you're running in, of course, because you can have Next.js on Vercel, you can have it self-hosted with like many different combinations, but it can potentially cause the like Lambda spinning up to call another Lambda, which even when you are very creative, it's probably, I haven't think about it too much, but probably maybe there's a way to even create some loop inside of server actions if they are calling each other. That's definitely something. And we had a very similar story about optimizing the application. And we were talking to Vercel team directly, and they recommended us that even though it's not explicitly stated in the documentation at that point in time, to limit to, like you said, mutations and to the client calls. And then there's this nice API that you can use with all of the next server-side features that are coming out, and it's very convenient. But yeah, it's a very common trap. So good that you found it.
Yeah, no, some other colleagues found it who are way brighter than me, but I'm happy they found it because this was giving me headaches at night. But yeah, indeed, server actions are very convenient because you can leave all your secrets on the server and just call it and have a hidden call a bit. So it seems a bit secure as well, but yeah, this is really the trade-off. And if you don't know this, then you're like, hey, why are my response times so slow? And especially when you're running at very big scales, these things get lost in the logs because we are calling like 40 APIs or something. And then you see those couple of post requests are easily missed, which are hanging. But only with the next link where we're really spamming the server actions, it came to light. So we have a lot of monitoring and dashboarding. We have the Kubernetes status pods. We have the CPU monitoring. We have profiling, we have traces, but it's still on such a scale. You have so much data to plow through that it's very hard to pinpoint for what is really the issue.
Yeah, exactly. Web is now more complicated than ever, to be honest. And even if you have, of course, the visibility is required, it's necessary at this point, because previously, maybe a few years ago, when you had only app written in JavaScript, that you didn't need this many systems to monitor like traces that going from the server side, but now it really is, and monitoring the memories and all of the like CPU of the pods and other runtimes that you're using. It's very important. One thing that you mentioned, I recalled that there's another like a common pitfall with server actions, which is basically the fact that they actually can be called even though there isn't. It's not just a regular GET request. If you just put at the top of the file use server, then all of the async functions are being exposed as endpoints internally in Next.js. And there are many attacks that are very like common, popular, because some people are just unaware that you're exposing those endpoints to the end user that don't even need to click through the application code that actually is triggering this server action. But you can just make it by the regular request. So it sucks a bit that we have to pay for the conveniency and in a lot of those places. But I'm very hopeful that in the future we'll have something that is easy to use, and also we don't have to worry too much about the hidden complexities and some quirks that you have to remember.
Those things are very new for us as front-enders to think about. Those were the days where we just wrote some JavaScript on the client.
Yeah, if you think about it, it's kind of funny, because if you look a bit further into the back, we made a whole circle, basically, like starting from the server side on the applications to the client side, and now going back to the server again, and having the same problems again, but on the much larger scale.
Yeah, so we go back to SPAs very soon now.
Yeah.
And some of the developers, I think they didn't used to using server-side actions or API routes, because when they working with front-end application, and then suddenly in the next, I guess, version 13 was introduced these kind of features, then suddenly they thought that maybe they can move the business logic or everything which is on client end to the back end, and this is zero cost in terms of the resources in efficiency, etc., which is not exactly true, because under the Next.js is Node.js, which is a single-threaded event loop. So every request, whether it comes directly from client component or server component or streaming or React server component, they all compete with CPU for rendering. So it's not like we can just simply move out logic to the server and don't have to care about this, because then we just shift the place that something is going to be proceed, but it doesn't mean that at the end the performance is going to be better. So I think the mindset of client of front-end developers also needs to be a little bit adjusted to the way we now build the pages in Next.js.
Yeah, so we need to remember with Next.js, you're writing code on the server, not only on the client, and the server you're sharing with other people, with the other requests coming in. So we are doing a lot on the server, rendering React, doing fetches, and all at once for all the requests coming in at one pod, so at one computer, basically. And normally we were used to write JavaScript on the client, and you were only using the resources of the browser of the client. So that's something, it might be a shift for front-enders to think about. And that's also a big topic nowadays, that we need to, what do we do on the server and what do we on the client? And I think before building a whole website in Next.js, that is something to think about, because the SEO related content, that should be on the server, and the content which you want to serve fast to the user, those should be generated on the server. But other things like user specific content which cannot be cached or is usable for SEO, you can just render on the client as well, if it's not trivial for your website to work. So that's a lot of that's where we need to think about. And also it's very convenient to write things on the server with Next.js, but you should really be aware that you share the server with other people. And also the problem is that Node.js is running single-threaded, like you said. And we try to mimic multi-threading with the event loop, but it's still single-threaded. So that's a problem when a lot of requests come at the same time. Your event loop lag grows and your CPU usage grows because it's doing a lot of things to mimic that multi-threaded with event loop and async actions. So be aware of that and monitor what you're doing on the server.
Yeah, definitely. There are a bunch of we have more toolkit, but we also have more headache nowadays, and we have to think about and worry about much more things. One thing that you mentioned about the amount of requests getting, that you have a lot of those people generating it that you are sharing with. Also, the single person is able to make a lot of requests unnecessarily if you don't have your application optimized. The case that you had with Next.link, for example, is very common, that people are just using it instead of the href, the regular one, the old good, but they don't realize that each enter of the viewport is actually generating a server call to prefetch by default. And if you have a large list of items, then it can very load your server and completely unnecessarily in sometimes. So that's something. Did you have this issue yourself?
Yeah, so that was also the issue with the server actions, of course, that we are basically DDoSing our own pods with a lot of requests. So you really need to think about, do I need the next link here to get that extra piece of performance, so that smooth transition from page to page? Or do I just want to use an href and let the server handle the request when it comes in? So that's something, if you have a list of 100 items, then next link might not be a good idea because you're sending a lot of requests to your application. So that's really things where you need to think about. And sometimes it's also unclear in the next documentation that is actually hammering your server. And like you said in the beginning, there's a lot of resources on, especially in front-end land, to fix the web vitals on the client. But on the server, it's really not known, because normally we would let backend people handle it, or the architecture guys, okay, we are serving not a lot of requests a second, can you fix it? And they push it back to us like, hey, you're DDoSing your pods and you're actually doing a lot on the server. So yeah, I think that's a common problem nowadays. And you get more and more information also on the internet and online about this. But when we first faced these issues with the pages router, there weren't very much resources available, especially if you run a self-hosted Next.js app. There's not a lot available to dig into fixing these problems.
Yeah, definitely. Next.js app router is there for a couple of years now, but it's still very fresh when it comes to the being actually having it on production and actually having scaling. The Next.js is the Versal team is updating it all the time to add support for Docker files, for example, and all of the different things that are actually needed if you are hosting it in the environment like Kubernetes. But of course it takes time, like with any other. And I really like we have benefits from the server, of course. The thing you mentioned is that the SEO content is much better to have on the server, to have it immediately shown to the client. And nowadays it's especially important just based on all of the AI tools that are being searching the web, because there are some still, like when we're talking about the new things and the fresh, there is still not yet one single protocol, like the schema that AI should use, that you should add to your site for the AI to read. It can read a bunch of different formats. It can read from the raw HTMLs to the JSON DLs files to the robot.txt files. There is also this LLM.txt right now that is getting quite popular, but there's not golden standard yet. But the truth is that the most important thing that you can do is to go back to the old good times and basically server sides your content, so it's immediately shown to the AI tool, and that's something very important for the tools as well, and not only for the humans and SEO crawlers.
Yes, but we had a lot of traffic from search engines, but now we also have a lot of traffic from AI companies scraping our websites. So that's also not a problem, but you need to be aware that a lot of traffic is added as well by that.
Yeah, definitely. It's widely popular right now, and also there are some proofs. I don't know specific numbers, but I know that people coming from the LLMs that are getting like a specific recommendation for the product instead of just browsing it and finding themselves have like much more higher chance to actually convert to actually buy the product. So yeah, it's important for every single e-commerce right now. Going back to the problem quickly, you mentioned some path of the investigations that you did to actually find the issue. You mentioned like trying to make everything static, thinking about like moving the traffic through the pods to optimize it with caching. I want to ask you, Tomek, if there is something on the infra side that you can do to take a look to pinpoint the issue, to maybe find something that there's something wrong with identifying any bottlenecks.
I think there are several things that we can look at in terms of infrastructure, especially Kubernetes, because Kubernetes is a very powerful tool and usually is chosen by many teams because it promises scalability, reliability, or portability. But on the other side is very complex, so it's very easy to misuse it, misconfigure it. And it's not like we only deal with the application itself, but there are several layers which are added on top of it, like CDN, load balancer, there is ingress controllers, there are some services, workloads, pods, etc., some networking, autoscalers. So if one of this is badly configured, it definitely can cripple the performance. Mm-hmm. So I would say there are a few points that maybe is worth to look at. First one, not all of them I experienced in production, honestly, but at least I am aware of them. Not sure if you also, Trystian, maybe had the issues like this, so maybe you can also share your thoughts on it. But for example, first thing that I would like to look at is the Nginx ingress buffer. Because when request goes to the pod itself, before it being sent back to the user, and there is Nginx ingress controller buffer within it, and it by default has like 16 or 32 kilobytes. And when we use SSR on Next.js side, which is quite heavy because there are not only HTML code but also scripts and parse JSONs, definitely we can very easily exceed this limit. What leads us to situation that Nginx rather just smoothly responding with the response is just hanging out because it's rather than using memory to save the response has to write it in the files within the storage, which is obviously much slower. So this is quite common mistake when we use Next.js and also Nginx ingress controller. And even though the pods itself are efficient enough to respond, so app is very efficient, the pods are fine, there is no need to scale it. The bottleneck is completely in a different place. So because there are several layers, as I mentioned before. Another one maybe which is also worth to mention is maybe keepalive connection reuse. Each request that goes through load balancer on Nginx has to do the handshake, TCP/TLS handshake with pods, which also takes some time. Obviously, it's not too much time because it's around maybe 100 milliseconds, but still, CPU in the pod, in the Node.js, it's not focused on rendering page, but instead is focused on having handshake. So I think this feature should be turned off, so we keep the session alive and we can reuse it simply. So we don't waste our resources for unnecessary handshake. So this is also the second thing that I found that some setups struggling with. And maybe the third one which came to my mind is the session stickiness. For example, if the request goes through load balancer, and we have session stickiness enabled that is based on IP address, then everything is fine. So this IP address and this particular request goes to specific pod, and everything is fine until we reach a lot of requests, which come from the same NAT gateway. Because, for example, we may have a situation that there is an organization and there is 1,000 people or more or less, and they all are behind the same NAT gateway. And every IP address from them is the same. So when they go to the page, every request from them goes to the same pod because there is a session stickiness enabled. As a result, the rest of the pods are staying idle, whereas the one is completely overloaded. So it is also quite common issue in terms of the scaling. I mean, the Kubernetes itself.
It's crazy that those type of issues can actually affect the LCP for the page. Like we have, because like when you have dynamic page, we have to first render it and then just show it to the client. And it's actually like things that were completely abstract to the front-end developers for a long time right now can affect the performance of the page. And I don't think many front-end developers themselves, like if they're not called themselves full stacks or like don't have any experience with infrastructure, clouds or backend, are thinking about any of those issues that can actually be causing this much of an impact. So it's definitely interesting. And Trystian, do you have any, like you mentioned that you managed to actually fix this issue at some point, right? At least you have an improvement. Do you have any like further investigation that you did to, for example, know that it was an infrastructure issue and not something else that was going on?
Yeah, so I heard a lot of interesting stuff now. So I'm going to
Feel
back
free to address it, yeah.
To the infrastructure guys to check that and see if we have that enabled. So that would be very nice. What we are also are thinking of is bringing some backend services, deploy them in the same cluster, so you don't have that whole overhead from cluster to cluster in Kubernetes. That might help as well, because in what you're also saying, you have a lot of overhead when calling a service, but when they are in the same cluster, it gets way easier, and that might shave off a couple of hundreds of milliseconds as well. Yeah, so we did some improvements at the infrastructure level as well to find a sweet spot, like how much CPU should we use and when should we scale. So Node, with traditional Java application, you might want to have a big pod with a lot of CPU power serving a lot of requests. But with Node, we found out that it's better to have small pods which serves maybe some less requests a second, not as less as we have now, but it benefits from, because Node only uses one CPU, then it's better to spin up a lot of small pods which are cheaper and can serve less requests a second than having big expensive pods which where Node doesn't benefit from. So those things we also find out during the process, that running a Node.js application is way different than running like a Java app or something. And maybe to touch upon this a bit, it's very hard to find that sweet spot from what CPU you want to use. I think if you dig a bit online, they say a Node.js application benefits from 1.3 to 1.5 CPU, one CPU for the application itself and half CPU for the event loop, because that's all it can use. But we are now looking into performance testing, both locally and with autoscaling. So we set up an environment where we mock the whole outside landscape. So all APIs are mocked with a mock server. So they respond just the same data which we tell it to. And we do that because otherwise you're load testing your whole landscape and you're load testing all services. But we want to test what happens in the next application when it gets a lot of load. So we managed to just mock every outside servers of our application. And then locally on your computer, you can run the app in a Docker container, because you don't want to just run it on your MacBook, because our MacBooks are very strong and also have outside influence. Maybe you're watching Netflix during running a load test and your computer is busy, and then you get less requests a second. So what we do is we run the application in a Docker container with certain CPU and memory, and then we start firing requests at it with AutoCannon or any other tool. And then you also can attach tools like Node Clinic to see what is happening to your application. And this is a way where you very fast can find these kind of issues, like if I don't render this component and fire my load test, can I get more requests a second and better response times? Or doesn't it matter? And then you can also find the culprits of your applications, but it's kind of hard to set up. But I think you can benefit a lot from it, because these issues, like we are talking now for a while, are really trial and error. What works and what doesn't work, because it's not one silver bullet which is going to solve all your issues. It's usually a lot of small things which are going to solve your issue. For example, you can also, with a mocked API layer, say if all my APIs respond within 300 milliseconds, how many requests a second can I then get out of my application, and what are the response times, and what if they are slow? And then you can identify what the API layer is doing to your application. And I think those things are very good to use to really push your app to the limits. But that's locally, it's only on one pod, of course, because you have one Docker container where you fire requests to. And then later on, you can also use a load testing environment to see how does it scale. And then you can use that environment to try out different pod configurations. Like, let's see what it does with 1.6 CPU and more memory, or what do we, when we have a smaller pod, but we scale up earlier, and that kind of stuff. So I think performance testing for these kind of issues is trivial to find the culprits, along with all the traces and the profiling you have, of course. But yeah, I think I would advise, if you have these kind of issues, to set up a load testing environment so you can see what load you can handle in what cases.
Exactly. I would say the load test is something that we should have set up on the day first in every project. Otherwise, we cannot really simulate situation that we may run into on production. And also staging environment should be some kind of mirrored with production, so we can do the load test against it and spot some issues before they reach the production. And also, I think I mentioned earlier a bit about the front-end developer mindset. Sometimes it's like that we write a code locally where we don't have additional layers of infrastructure, and locally everything is working fine because there is no load balancer, there is anything else that can add additional latency. But when the same code goes to staging, for example, rather than responding with 200 milliseconds, it responds with 2 seconds. That's why load tests are so crucial for every application to spot issues before they really hit the user.
Yeah, famous.
Yeah, exactly. Yeah. No, exactly. I think this is a new mindset within the front end, which we should embrace. I think for front end, it's not common to set up load tests and performance testing, because we are not used to it, but we need to remember that we are slowly becoming back-end developers as well.
Yeah, definitely. Remember that the times have changed. But I really like your approach to testing. So you, first of all, it's very easy to test the things that you don't actually want to test by accident. If you, for example, didn't use the mock service worker, you can be testing on the separate, the third-party API that you have or something instead, and then have completely, the whole test results will be completely to put to the trash, because you wouldn't be actually testing what you were supposed to. But also, I like the fact that you can narrow down with it. Like, you can just abstract some kind of APIs, but you can see then how, specifically how your app is performing. And so it's very good to also investigate and pinpoint the issues that you're having. So yeah, very, very good approach, and very, very good recommendation for people that are struggling with similar issues with scaling of the server.
Yeah. And one question to you, Trystian. In terms of the scaling, you mentioned that rather than having one heavy pod with several CPUs and memory, there was a proposition to switch to smaller pods with less CPUs. And is this something what you actually did, and did this play out fine in terms of the performance? Was it somehow measured that this approach brought some relief to the servers, and as a result, more requests could have been managed?
So you won't get more requests a second per pod, of course, because you're using smaller pods. But maybe your cost goes down because the smaller pods are cheaper. And we are now running pods which have a minimum of 0.66 CPU, so a minimum. They can have more, so we just see what's available and run them, and then scale up at around 80-90% CPU. And we saw that was actually somewhat better and easier to run. But we are still, with the load testing, trying to find that sweet spot with what kind of pods we want to use. But I just want to say, with Node.js applications, the bigger and more expensive computing power is not always benefiting your application because Node is single-threaded.
Yes, there are always some kind of advantages and disadvantages from every solution, and they just need to be adjusted to the real scenario that we deal with when it comes to specific clients, specific code, specific business outcomes, etc., etc. So sometimes horizontal scaling may be more efficient, sometimes vertical scaling. It always depends on the use case that we deal with that need to be investigated deeper.
Yeah. If one machine is enough, then why add the second one? If you can just add 10% more, for example, vertical scaling could be completely fine for a small application, but yeah, it's not really the case for the enterprise. Okay, I think that this is something that we can use as a takeaway from here. So that's like, we don't have a single solution to the performance issues on the server, unfortunately. Each of those have to be adjusted. There are a bunch of different parts of the application that also can be affected. Even identifying if the problem is with the application or the infrastructure that the application is running on can actually be an issue. And if we identify where actually the issue is, like if it's, for example, the infrastructure, it can be either the resources issue, some scaling, some like a bunch of different problems. Or for example, for applications, can be a logic that you did, the framework that you're using, the web connections that you have that are hanging. So there's a whole complicated world that has to be treated case by case, unfortunately. But I think we covered a lot of different points that people with similar issues can actually verify on their own infrastructure if that's something that they are struggling with on their application. So, Trystian, you want to add anything?
Yes, I think you've covered it quite well. Yeah, just remember the server is shared, so be careful which code you write on it. Try not to block the server for other requests which are coming in. And server-side rendering is just expensive on the CPU. So don't try to mimic the amount of traffic you can handle with a simple API, because you're doing a lot more than just serving JSON data. And please just check which things need to be dynamic and which things can be static. I think that's important, and do that before designing your application, because usually when people are going to rewrite to a Next.js app, they are just starting to rewrite all the pages inside the Next.js app, and they are not thinking, hey, this code executes on the server, this is on the client, because Next.js also makes that very easy to do. But in the end, when you get these kind of problems, you're like, oh, maybe this page could be static, or maybe this page we should have optimized more. So start optimizing and load testing in the earliest stage as possible, because otherwise, just like us, you will be behind, and then you need to fix all things in hindsight while people are developing features. So we actually, as a team, also said with those problems, now we need to really dive into these issues, and we improved a lot on all areas. So like on the server-side code, on CI/CD, on infrastructure, we handled all parts of the application where they run and build an application architecture, and we were able to solve a lot of issues because our response times are way faster and we are serving more requests a second. So I think that's a key takeaway, to start as soon as possible with this kind of stuff, because it's very complicated and there is no silver bullet which is going to solve it all, because solving these issues is very frustrating, because twice a week you have an idea, hey, this is our issue, I'm going to solve it, and then on production you don't see any effect. You don't see like the response times getting quicker, and you don't see a lot more requests a second. So it's really a lot of small things which will make it better.
Yeah, there are so many different options that you can do that there's very rarely it's only one thing that is actually causing an issue. Great. Thank you very much for you both. Thank you, Tomek, for being here, and thank you, Trystian, for joining us. Wrapping things up, Do you have any advices for the companies using Next.js struggling to actually have some amount of requests per second or to handle like a backend side of the rendering phase efficiently?
Yes, I would say that they have to have load testing prepared and set up at the first one, along with observability. This is must have to be able to reproduce the load on the pre-prod environments. And also I would advise to use server-side rendering only if it's truly necessary.
Okay, so just to be aware that there's a cost to it, right? There's a lot of different cases that are actually requiring server-side rendering, but whenever it's possible to go static, just go static as a rule of thumb.
Exactly. So CDN can absorb up to 90% of requests, and we don't even touch infrastructure behind it. So server-side rendering is a powerful thing, but only if really necessary. So we need to display dynamic content, and there is no excuse for that. We cannot manage this differently. But if we can, then we should avoid SSR and go with SSG or ISIR in this case. Yeah.
Thank you for staying till the end. Thank you, Tomasz, for joining this episode.
Thank you very much. I really enjoyed being here. Thank you for having me.
Hopefully we will have you next time as well for a different topic. Don't forget to leave a like and subscribe and follow us on other social media, and see you in the next episode.